All right, everyone. Let me welcome everyone back. We want to keep this moving a little bit. We're going to continue with the second half of the Shure presentation today. We're going to talk about wireless workbench. Before we continue, did everyone sign up? Has anyone not signed in? Very good. Again, we're going to raffle off a bunch of stuff throughout the day. We got a $1,600 Chrome ULXD that's on display here. It's a beauty. We're going to raffle that off. QSC has given us a GX5 amplifier. Yamaha has given us some headphones, and we got a bunch of swag and stuff like that. Probably in between the next, after this presentation, we'll probably raffle just a few things off. We'll trickle them in throughout the day and then do the big stuff towards the end. But thanks again for coming. Thank you, QSC, Shure, Yamaha, Data Video, and My Live District for all helping make this happen. And without any further ado, I turn it back over to Chris.
All right. Well, if I didn't put you to sleep earlier, I'm going to try really hard now. Joking. I think we're moving on to something that's a little bit more, hits home a little closer, things we all deal with every day, and that is antenna setup and RF distribution. At Shure, oftentimes we get calls with two questions when we're setting, there's two issues that become evident when people call in and they're dealing with setting up wireless systems. One of those things is antenna setup and the actual signal distribution, and the other thing is RF coordination. Those are the first two places where things fall apart for wireless in installed sound, or portable sound for that matter. Let's tackle that first section here of antenna setup and RF signal distribution. So what are the things that you need to know about antennas? We're going to cover things such as how many systems should I consider before I use antenna distro? Why should I move my antennas away from the receiver? Maybe the receiver's stuck in a rack somewhere back in a whole different room somewhere, hidden away from the transmitter. Or maybe I'm at a stage that is 100 feet away from my front of house position or more, and I need to get good antenna reception from wherever my front of house system is. So hopefully we'll go over all this stuff today, and you'll leave knowing and feeling like you're an expert. You can set up antenna systems and be good to go. So we'll also include what antenna types there are that are most used in UHF wireless, I should say, where to put those things to make them most effective, and then other considerations you may need to take into account when you are remoting the antenna away from the receiver. Finally, again, antenna distribution. So we should probably start with some of the technical stuff first and actually look what a radio wave looks like. If you're not familiar, there's two components to a radio wave. It's an electromagnetic wave, unlike a sound wave that spirals, a sound wave spirals through the air. An electromagnetic wave actually has two axes. There's a magnetic field and an electrical field that operate in tandem based on the axis or orientation of the antenna. So in this case, if my antenna is placed vertically, I have my magnetic field in the horizontal plane and my electrical field in the vertical plane. Here's a quick equation that you'll need to know. We'll give away a free wireless system once you explain that. We'll move right along. This is just a wave equation. It applies to anything that is a wave. It could be ocean, waves on the ocean. It could be acoustic waves. The takeaway from this slide, really, is that as you notice, as I go up in frequency, the wavelength gets shorter. Go down in frequency, the wavelength's longer. So if we look at VHF around 200 megahertz, I'm at about 1.5 meters. 1.5 meters is approximately how many feet? Times 3, right? So we're at like 5 feet. If I look at, let's say, 600 megahertz up in the UHF spectrum. Now we're down at a half a meter, about 2 feet, right? This propagation that happens out from a transmitter there's several things that can affect it. First of all, metal objects are the death of anything RF. You may already know this, but the reality is, if my wavelength is shorter than the metal object is, it completely blocks out that RF transmission. So my receiver is unhappy, as you can see there, a nice little picture. However, if my metal object is smaller than the wavelength, it just passes right by it as if it's not there. Great. Fully functional operating wireless system. But what happens if I have a metal obstacle with an opening that is greater than the wavelength? Great. We're happy. And then finally, this one is a good one. If my my opening of my metal obstacle is smaller than the wavelength, again, it sees it as a solid wall and just won't pass through it. And the perfect example of this is when you look at your microwave oven. RF extends on up into visible light spectrum, right? It's still electromagnetic spectrum. How is it that you can peer into your microwave oven and see what's going on in there, but the microwaves don't come out of the oven and cook you? It's this principle right here exactly. Every microwave has that metal mesh on the front, and the openings of that metal mesh are smaller than the wavelength of the microwave, allowing visible light to come through, but no microwaves to come through. And thus we're all still alive. So antenna types. Let's talk real quick about, again, these antennas that we all use that are specific, again, to UHF type wireless systems and or VHF. First off, antennas are transducers. So for those of you that know about transducers, a transducer could be a microphone, that's an input transducer. A speaker is an output transducer. Well, an antenna is a transducer as well. It converts electromagnetic waves to electricity back and forth, right? That size of the antenna is directly related to the wavelength of the transmission or the reception. So this is important as well. Again, back at that VHF example, we're about at 5 feet for that full wavelength antenna, whereas with UHF, we're only at about 2 feet. You can start to see where UHF is kind of beachfront property. We were talking about this just a little bit ago. With all these auctions and stuff coming on, why are we still in the UHF TV spectrum? Because it works really well. That's why everybody else wants to be there too. Why Verizon, Sprint, et cetera, want to be there. So also the design of the antenna determines its performance. Is it directional or is it omnidirectional? Is there gain associated just inherent to the design of the antenna? Or maybe does it have an amplifier built on as well? We have some antennas that have that. We'll see that in just a minute. And then, of course, the bandwidth that that antenna actually covers. What section of the spectrum is it able to peer into, so to speak? And certainly when it comes to Shure systems, all of our equipment is set up to be compatible with 50 ohm antennas. This is going to become really important later when we go to talk about cabling. Cabling matters, and all of that cable needs to be 50 ohm as well. So having a quick look at this, here's a polar pattern of an antenna. And what you'll notice here is that this polar pattern actually represents if I was looking down from the top of the antenna. This polar pattern represents if I'm looking at the side of the antenna. So oftentimes when people talk about omnidirectional antennas, you need to consider how you're placing that antenna. We'll get to some points here in just a little bit, but we get calls, usually starting about this time of year from churches especially. And A lot of times they brought in a bunch of extra wireless and they put the antennas right on the back of the receiver, and we say, where are your antennas? They say, well, they're on the receiver. Great. Where are they pointed? Well, they're pointed right at the stage. Well, that's kind of a problem, right? They tend to be less sensitive at either end. The omnidirectional is perpendicular to the orientation of the antenna itself. Ah, well, there's the picture of it. It's kind of hard to see. But there's the receiver with the antennas in it pointed straight out. So half-wave antennas, these are great antennas. They're often referred to as telescoping or rubber ducky type antennas. A half-wave is required anytime you are going to remove the antennas from the receiver and place them out in space somewhere, whether it's flown or on a mic stand or something. A half-wave antenna is the minimum antenna that you want to use when you do that. And the reason for that is it operates independently of a ground plane. The little pictogram here shows kind of electrically what's going on. This is an end dipole type antenna, meaning that there's a cable that comes in the bottom here, and then somewhere in the middle it actually splits, and we have the transducer on both ends here, kind of creating its own type of ground plane, basically. Other wireless systems, like SLX, for instance, ships with quarter wave antennas. BLX-R also ships with quarter wave antennas. These must be attached to what's called a ground plane of some type. They can't be remoted out into space. As you'll notice, there is no separate dipole on a quarter wave antenna. It is strictly just a quarter wave piece. And connected to a ground plane means it could be connected right to the metal rack ears that come with the units, which is a great thing. They could be connected on the back as long as, again, they maintain their proper orientation. So quarter waves, not good for remote mounting. They have to be mounted to a ground plate. And then, of course, we talked about bandwidth. These are, the part number is actually a UA8. And these are somewhat band limited. They're only about 60 megahertz wide, which works out well for most of our receivers. We do happen to have also a wideband Omni, which is the UA860, and that's depicted there. Bandwidth is 630 megahertz, so extremely wideband. That gets up into 1100 megahertz. These are passive antennas, so they can be used as either transmit or receive antennas. They work well for both. The UA860, the wideband, is a really nice one to use for in-ears as well. I'm sure everyone's familiar with this as well. Sometimes it's known as the shark fin or the paddle, but technically it's actually a log periodic mic. Question?
Going back to the previous microphone, the larger one, is that increasing range because of the design?
Yes, based on its design.
You get more distance from that microphone rather than, as well as more, skipping the bandwidth issue, putting the bandwidth issue aside, you getting more distance from that microphone?
Oh, no, there's no additional distance or anything. It's still just a passive. There's no forward gain. There's just a passive Omni antenna. So the log periodic antenna, or Yagi, it's kind of hard to see here, but if you've ever looked at one up close, and we have one in the back that you can see, there's actually different elements that come down and they're placed. And as the antenna gets shorter and shorter in length, they also get closer and closer, hence the name log periodic. It's a logarithmic function. That design actually works well for increased or harsh RF environments because it has some inherent forward gain automatically, about 7 dB of forward gain. And it also has a rejection at the back of the antenna. So it's kind of like a cardioid microphone and as far as what its pickup pattern looks like. You point it to where the stage is, and then if you're smart about it, you make sure that the TV towers at Mount Wilson, if you're in LA, is at the back of the antenna. So now it's rejecting all those TV antennas and focusing in on just where your transmitters are. Cool. Also, this antenna is good for long range. You know, again, you don't want to use this type of antenna if you're like less than 100 feet away from your transmitters. If you're closer to your transmitters and you use an antenna like this that already has some inherent forward gain, you actually can overload the front end of your receiver, which ironically gives you the same problem as not enough RF. Too much RF equals dropouts, not enough RF equals dropouts. So we've got that question too. A lot of times, hey, I've got this directional antenna, I've got it set to plus 10 dB or plus 12 dB, and I'm 5 feet away off the stage. Pad that thing down, you know, let's get it under control. Can you use an Omni? These are all good, important points. Do we have a question?
Yeah. So would that is it adjustable, the dBs, so that if you're closer, you can?
Thank you. Great point. Great question. It's worth it for you to look at this. The new and improved UA847 is the part number for this model. The new version, yes, does have 4 settings: -6, -6, -3, 0, and plus. I am having a total. It's minus, what is it, Ben?
-6, 0, +6, and +12.
There we go. Thank you. All these 6s. So yes, you could potentially have it closer and be able to pad down your RF environment. The other reason why that's important today is because as our digital TV stations become more and more packed and condensed, it raises the overall RF noise floor, which desensitizes your receivers. So if your antennas are wideband and your receivers can see all this DTV stuff coming in, it starts to desensitize the receivers. So an antenna like the UA874 will help in the sense that you can get it closer to your stage, pad it down, which drops that overall RF noise floor, and have it have a clear picture to your transmitters. So, yes, again, question? Hang on. I'm sorry, I can't hear you.
So how do you give some kind of specifications on the distance and how much you reduce on the antenna?
It's like somebody's paying you. We're going to get to that in just a second. Okay. So again, as I mentioned, typically directional. Yes, question.
Because there are some of those paddle type antennas that don't have the amplifier on it.
Great point. So the point again was
Am I just following into his question? You're going to come to it? I just wanted to get on TV, really. That's all I was doing this for.
Perfect. Hi, Mom. Yes, we do have a PA805, which is a passive log periodic antenna. It still has that inherent forward gain. It's 5-ish dB, 7 dB, but it does not have the antenna amplifier on board. Right. That works well, by the way, just so we have a quick discussion on this, because this topic does come up from time to time. When you're using an active antenna, meaning an antenna that has any kind of a power amp on board or circuitry on board, that's a receive antenna. You can't turn that antenna around and make it be a transmit antenna for your ears, for your in-ears. Only receive. So the PA805, as we just talked about, is a passive version of this antenna, no amplifier on board. It could be either way. It could be a receive antenna or a transmit antenna. And by the way, it's a very popular transmit antenna for ears. So I think we kind of mentioned all this. Of course, to point out, you've got to make sure that you're within its angle of acceptance. Just like a microphone, you wouldn't talk into the back of an SM58. Nothing happens really. Same thing here. And then, of course, you're choosing passive or active, typically based on your cabling, what type of cable you use, and cable length. So we're starting to head towards those questions. There's another antenna type that is available from Shure. We don't actually build this ourselves. This is available through another company who builds it, Professional Wireless. We just distribute it because it's a heck of a good antenna. This is called a helical. And it is extremely directional, 60 degrees directional. It is a passive antenna. And it has 9 to 11 dB inherent forward gain, which is great. Of note, this antenna has no polarity associated with it. It's non-polarized because of its helix nature, the way that the transducer's wrapped around inside that tube. So as we had mentioned already, this has a polarization to it, right? If it's this way, I have my electromagnetic wave emitting or receiving a certain way. Same, if I change it, that polarity changes. That doesn't happen here. So this is another popular transmit antenna for ears because no matter where that pack is located, maybe it's on the strap of a guitar, it's in somebody's back pocket, no matter where the antenna on that pack is located, it doesn't suffer from a polarity related issue. What does that mean? If my antennas, if I have a transmit antenna in a vertical plane and a receive antenna in a horizontal plane, I have loss. There's some amount of loss. Perfect orientation would be this way. Great reception, perfect, rock solid, great. The other thing that comes into play here, though, is we actually, as transmission happens from a transmitter, it bounces off of other metal objects and around. And all those get into the receive antenna as well, at a different polarity, by the way. So, if nothing else, hopefully you're starting to see the antennas are important, and so are the head end of receivers. Because receivers, the more you pay, typically, the more you pay, the better that head end of that receiver is, the better the filtering is, the better it can make sense of those signals coming in. All right, let's work through placement. This is kind of based on what we just talked about here. We've got this electrical field. We've got transmitters that are bouncing off of the metal devices here and there, changing the polarity. So what do? Well, ideally, you could actually do the classic rabbit ear style setup on your antennas, so that as my transmit antenna changes polarity and reception, I have some angle here to hopefully pick up, and then the receiver decides which antenna is working the best. You could also place them this way. Doesn't really matter. As long as I have about 90 degrees separation at an angle, I got good things going for me. The next question we often get is, what kind of spacing do I need between these antennas? Well, you can't get them too close together. If they get too close together, it just starts acting like one antenna. You lose your diversity. So at least a quarter of a wavelength apart, minimum. Best is a full wavelength, so about 2 feet apart is the best. Now the reality is as you start going further apart than 2 feet, you don't really gain much. Once they're past one full wavelength apart, you don't lose anything, but you're not really gaining anything unless you're trying to get an antenna closer to a transmitter somewhere. That may be of benefit. Two questions.
In some situations we've had where our front of house is set up sort of at an angle from the stage and the other with the paddles, technically we're sort of one behind the other. Are we gaining, losing anything? I assume everything's a sacrifice or a trade-off, but is there an inherent problem with doing it that way?
You're always going to have multiple arrival times, but now you potentially have multiple arrival times in succession, which is almost creating an antenna array. You would be better off, if possible, by either one front and back. Of course, you'll never be able to do that, right? Yeah, yeah. So even...
Pull this one
Right. So
Make it more of a flight plane?
if here's the front of the stage, first of all, and we'll get to this too, but height is your advantage. If you can get them up higher, that's also good. But maybe I have one on plane with the talent, and then I can get another one, get some separation this way, back, point at the talent that way too. You could also do left and right if you wanted to, of the stage.
Pointing at each other?
Sure. Because then, actually what happens then is if it's a pack, like right now I've got my pack on my side, and also this big sack of seawater, I wish it was less, is a great absorption of RF. So as I turn this way, and my receiver, where's my receiver? It's back there somewhere. I'm actually blocking myself from the receiver. But if I had an antenna on this side, I wouldn't so much. So all these are options. There's no always right way. Everything's always a compromise in everything we do. And there was another question in the back.
Yeah, you spoke about the perfect orientation between the antennas.
Yes.
But in actual reality, most of the body packs have kind of like a flimsy, kind of not really upright, standing antenna.
Yes.
How do we fix that problem? Because it looks like the manufacturer makes it like that.
It's perfect. What's the problem?
Well,
Not really. It's probably just easy. No, I think I got one in here. Yeah, so what you're referring to is this guy, right? And I've done a lot of church sound, and I can't tell you how many times the pastor does this, and wraps it up behind, and then sticks it on, and you're going, oh my gosh. Somehow it still works usually. But how do I keep that vertical orientation perfect? How does that happen? We know that's not going to happen. On Shure body packs, by the way, you could flip the clip so that the antenna is pointed down. Sometimes that may not be visually acceptable. Guitar straps are another one. A lot of times guitars will put them on sideways, and then the antenna's going this way. So the point behind the antenna the orientation of your receive antennas is that if you give yourself some amount of orientation this way, it hopefully will compensate for whichever way that pack is going to turn and give your receiver a chance to actually have good line of sight to that RF. Another question.
What's your opinion on going guns,
The question was, what's the opinion about doing a splay on the Yagi antennas? And that's actually a good practice. It's perfectly nothing wrong with that. The challenge is how to do that, because there's a mic clip on the bottom that keeps it. Yeah, Shure doesn't do it. However, you can buy accessories from different mic stand companies that will go right on top, and will allow you to change the orientation. No. The question is, does it matter for distance if I change the orientation? No. This is another one too. Again, as I had mentioned, it's important. Antenna placement is important, so is your transmitter to antenna relationship. You really need to be at least 10 feet away from your receivers. Sometimes people will call and say, we're just having a hard time getting our receiver to stay online. It keeps dropping. And we might ask, where's your receiver located? And after we've gotten through all the antenna questions and everything, the solution may be to move the receiver closer to the transmitter. However, if you get too close, we've already kind of mentioned, you get too close, you could overload the head end of the receiver. So minimum transmitter receiver, 10 feet. Maximum, kind of depends. That's where it gets magical. Height is your friend. As I had mentioned, all of us humans are big sacks of seawater, and it turns out RF doesn't like to transmit through anything much. In fact, it works the best in a vacuum. When there's nothing, outer space, RF transmissions will go forever. You may hear about, people that are listening into the RF transmissions of stars that are hundreds of millions of light years away. So once it gets into the air and propagation happens and sacks of seawater, it tends to die quickly. So if I have my audience here, the last thing I want to do is have my rack of wireless systems sitting down on the floor or antennas down low. I need to get them up so it's line of sight. And line of sight literally means that. Best case scenario, my transmitter always has line of sight to some antenna somewhere. When you consider, keeping a minimum distance of a quarter wavelength apart from parallel metal surfaces, what that means is you don't want to go into a place and and connect an antenna right to a wire, an aluminum beam, let's say, or steel structure or something. It could be perpendicular to, or if the beam was the other way, it could be perpendicular to that, but you don't want to have them running parallel to each other. You also don't want to have the antenna farm either one of these. We kind of talked about this earlier. The antennas actually start to make their own array, and so an omni antenna, which once was omni, starts to become directional in some lobe or some way that's completely unpredictable. So ideally, again, you're connecting to some surface, and this could be metal at this point. It could be the rack. It could be the top of a metal rack if you're doing an install. It could be installed permanently on top of the rack, perpendicular to that metal surface. Cool? There's the picture of what was just asked about. So, I don't know, somebody's been paying all you guys this time. This is an installation where they had the great idea, we're going to use directional antennas, we're more than 100 feet away, we need some extra gain, makeup gain to get through the cable. I want to have some orientation that is appropriate so that I have great reception. However, this is also a multi-use facility. This call came in and said, our system isn't working. We thought we did everything right. What happened? Well, if you'll notice, I mentioned this is a multi-purpose facility. It's inside of a metal mesh cage. The volleyballs and basketballs don't get in, but neither do their transmitters. So that's the perfect example of a Faraday cage, and they didn't know that they had created one. And again, back to this picture, having antennas plugged right into the back of the receiver pointed at the stage, not such a good thing. It's also inside, this happens to be inside of a steel enclosure, which is not good. And here's the rack with the antenna farm on top, way too close together, creating some erroneous lobing of the antennas. So you might say, well, what do I do? I've got all these antennas, I'm going to put these systems in, what do I do with that? Well, that brings us to our next topic, which is, whoops, I jumped the gun. That's not our next topic. We're going to talk about antenna cables and considerations, then we're going to get into distribution. So if you're trying to get your cables out and your antennas out into the space, you need to consider some certain things. I had mentioned earlier that 50 ohm is what the impedance is of our antennas, as well as our antenna connections on the back of the receivers. So you need to use 50 ohm cable. RG58 is pretty popular. However, you would need to keep in mind that it's pretty lossy. So keep RG58 runs to about 20 feet. 213 is much more popular, especially in production work, because 213, you're pretty good with that up to 100 feet. You're going to lose. These tables actually show this. And by the way, this information's available on our FAQ section at Shure. But if we can drop the picture-in-picture real quick, that'd be great. You'll notice here that at 200 megahertz per 100 feet, it's about 3 dB loss. At 400 megahertz, it's about 4.8 dB loss. This is showing loss in meters on this side, so that's the difference between these two platforms. But if I can keep my total loss down to about 5 dB, I'm in the acceptable range. So 213 up to 213U, I should say. And it's still nice. It's a pliable cable. It's a braided shield, with a stranded copper core. But what happens if you need to go further? Well, here's some other examples of 50 ohm cable. Here's our 213. There is an RG8XU, which is a little bit thinner. Again, it's a little bit easier to use. But you're up to 10 dB loss at 650 megahertz. And you'll notice how the higher in frequency I go, the more loss I have. And the cable manufacturers will produce, like for instance, I see West Pin Wire on the shelf back there. They make a cable, I think it's called the 810. They produce an actual diagram that tells you they've swept it at certain frequencies, and you can look at that and take an estimate at about 50 feet or 100 feet or whatever, how much loss you're going to have. and at what frequency. That was the big point. If you need to go real long distances, you need to be using something like an RG8U cable. Word to the wise, if you're going to use RG8U, you better have some muscly guys around. That cable is a 1/2 inch diameter, has a solid copper core. It's a big moosey cable, and it is not for the light of heart to deal with. You're usually soldering on connectors. However, that's what you have to use if you need the performance. You know, at 100 feet, I'm only 3 dB down. So very low loss cable, however, not super easy to deal with. You probably wouldn't take it on tour with you and roll it and unroll it every day, right? As a side note, in a pinch, you can use 75 ohm cable. That's acceptable. However, you're going to have loss in the impedance mismatch. So if you had to use a 59 or an RG6, RG6 actually works pretty well. But again, you're going to have loss due to the impedance mismatch. So what do? I'm using RG213, and I'm at 650 megahertz, and I need to use some makeup gain. How do I get gain back into my system if I'm losing that much? You use an antenna amplifier. And the one shown here is a UA830. I actually have one in the back. If you want to touch it, feel it, check it out. So of note, again, this is to compensate for cable loss through the cable. We often get asked the question, can I put the antenna amplifier inside my rack instead of having it out there, maybe installed on the wall somewhere? The answer is not a good idea. You could do it, but that's not a good idea, because what you're doing now is you're actually amplifying all of the noise that's coming in full broadband across that cable. You want to put that thing out at the antenna end and amplify what it's seeing at that end. If you need something that's more aesthetically pleasing at an install, we actually make an antenna called the UA864, and it kind of looks like an access point. This is much more appropriate for people that don't want to see something hanging on the wall like this, especially if it's painted some nice color or something. This is a directional antenna that also has an amplifier built into it, switchable again, -20, -10, 0, and +10 are the settings. And it's really easy to install and place. This is a directional antenna, if I didn't mention that already, so it's kind of a cardioid pattern. But you have options. So, but again, be careful with these amplifiers not to over-amplify. We don't want to add too much gain. And then here's the math, right? When it boils down, right down to it, if you add whatever the antenna gain is, plus the total boost or amplifier gain, minus whatever you have through that cable, and minus whatever you might have through a split loss, which isn't really shown here, but if we do make passive splitters, you're going to lose about 3 dB every time you go through some kind of a passive split. That should equal 5 dB or less. Cool? We should note that there's not really a requirement for symmetry. You don't have to have exactly the same two antennas. You don't have to have exactly the same lengths of cable between the antennas. You just need to be mindful of the loss you have through it and keeping it less than 5 dB. So in summary, when remote mounting the antennas, you always want to use the half wave or directional antennas, positioned for the best line of sight, spaced at least 6 inches apart, but preferably more close to 2 feet if you're in the UHF TV spectrum. Make sure you don't lose any more than 5 dB in the throughout the whole cable, and also make sure you haven't over-amplified. Now, the antenna distribution part. The reason antenna distribution is important, you know, a lot of times folks say, well, we don't have the money for an antenna distribution system. We're just going to buy 8 wireless systems and stack them all right on top of each other and have this antenna farm. Well, we already kind of learned about what happens when you have all those antennas next to each other, right? There's actually other issues when you end up stacking receivers that close together. They can start to interfere with each other. There's some chatter that can happen between all the antennas that get into the receivers and cause more problems. So we can passively combine antennas. Shure, again, I had mentioned we make a product that allows you to combine up to 2 receivers together passively. But beyond that, you really need to get into an active splitter system. And that's good for 4 to 5 systems. And then we can build from there out to build the world's greatest RF system. And please sell that or buy it. We would love for you to buy hundreds of channels of wireless. That would be a killer. Of note, between active distros, you never want to go more than 2 deep, meaning, and we'll get to this in a second, a pictorial, but just keep in mind you never want to go more than 2 deep of any distributed active signal. Here's what a passive system looks like. These are UA221s, fairly inexpensive, easy way to get a couple of antennas split. We happen to be looking at, these are older UR style receivers, the back of them, so these are 2-channel receivers. In this case, we actually would have 4 channels of wireless on the air with 1 set of antennas. Here's an active distribution system, 1 level deep. So in this case, this is a UA844 up top that's being distributed, signal distributed down to, again, those UR receivers. And we would have up to 8 channels on the air using that 1 distro system. Question? What? I'm sorry, hang on a second.
Are the newer UHFR series active or passive distribution on the pass-throughs on the rear?
Good question. You need to consider them passive. However, you can go, 10, 12 deep with that. Beyond that, the noise floor is too high and not really usable. So keep in mind, there are kind of different rules per product based on what their requirements are. Yes?
In the passive example you just had up,
Yes.
with those 2 splits, you mentioned the 3 dB loss. If you were keeping those cables exceptionally short, just in a small rack, for instance, would you still experience?
Yes, you would still have 3 dB of loss just because this is in the circuit, in the way. But if I'm, like you said, keeping them short, you might only have a total of 4 dB of loss or so. Okay. But what happens if I need to get more than 8 channels on the air at one time? So you'll notice here that we have a UA845 up top here, distributing out to these channels. And then I have a pass-through channel on the UA845. We basically make 2 different antenna distribution systems that are active, an 844 and an 845. The 845, the main differentiating factor there is that it has this extra cascade port out. So that's going to feed my second UA845, and then I can distribute out from there. So in this scenario, again, using this receiver, which happens to be a dual channel receiver, I have 16 channels up on the air now with a single set of antennas. By the way, these antennas are band limited. Remember, they're tuned to a specific band. So what does that mean for these receivers? They should all be within that tuning bandwidth of that antenna, right? If I had mixed systems, I had some maybe in G band, some in H band, some in L band, then I need to go and use a wideband antenna. But wait, I got lots of wireless to get on the... I think Empire's raffling off this system at some point, right? So in this case, how do I do that? Well, we've got one UA845 master distro feeding 4 different other distros, and we've got 8 channels receives times 4. We've got 32 channels systems up on the air. If you have more than that, give us a call. We can help do your antenna distro for you. Of course, Empire, been the local rep here. You got lots of technical resources to help you get beyond this point if you find yourself there. Yes, sir.
Had some circumstances we've had particularly wide rooms, but I've never seen anything where they did more than 2 antennas.
Right.
And I've run into specific things where I've had like a 3-step room with air walls.
Okay.
Getting the air walls partially blocking off, and we literally went to an antenna that we parked in front of the air wall to give us some wrap on it. But nothing seemed to offer putting 2 in this room and then 2 in each one of those rooms and bringing it all together that way. I don't have that kind of time, right?
We can help you design an antenna system that will allow for that. I actually have stuff that I left out on purpose that shows exactly how to do that.
Okay.
But yes, there is absolutely a way to split your antennas. Basically, this is called a distributed antenna system, right? Because we're going to distribute antennas into these divide combine rooms. Then you're just making up a decision whether you want like an A in room 1 and a B in room 2 and then an A in room 4 and a B in room 5. Or you could put, for true diversity, you could have an A and B in each one of your rooms. Absolutely, there's a way to design that. And again, Empire, Ben, or I can help draw that out for you and show you what it would look like.
Okay. These work pretty good, though.
Yeah, that's something we do quite often. We just, for one of Empire's clients, we just did a pretty sizable room combined divide, lots of different data rooms, lots of different stuff like that, and we did a full line drawing and everything. So if that's something that will help you out on the install or production, we're happy to help do stuff like what you see here.
To the question earlier in the back, RF cascade distribution, these are UHF-R pluses. They offer antenna cascade. Again, like I said, UHF-R, you're really only going to want to go about 10-ish systems deep by cascading this way. When you're using the system, that means you don't have to purchase an extra antenna distribution system. Or, again, this is another way when you have those shows where you're going to put 64 channels wireless on. This would be a way that you could continue to have all those channels on the air and incorporate the other UA845 distro for that. Are there any questions before we move on to the next section on antennas and RF distribution? Yes, sir.
Any concerns with mixing other gear into antenna?
So the question is there any concern, like if I was to use Sennheiser on my other systems or, EV or Telex, look, we know that all of you use 99% Shure gear, but once in a while there might be a chance, maybe, that something else is going to be used. The answer is no. As long as your antennas are wideband, our distros are wideband. Today our distros are wideband. Please note, there still are some UA845s and 844s from the past that are band limited, that only operate in certain bands, and you'll run into those potentially. But as long as the antennas are wideband and the distro is wideband, you could cascade some other manufacturer stuff in there and not have a problem. Any other questions? Okay. So now let's move on to the actual RF coordination part. Was like what I had mentioned was kind of the second half of what we often run into with issues. Okay. So some of you may already know what frequency compatibility is, but again, we get that call where you start having 3 or 4 receivers set up in a space, and if you're not paying attention to this frequency coordination thing, you may run into some real issues. Assuming you've got all your antennas set up perfectly, we need to look at minimizing these effects that frequency compatibility may present. So there is system-to-system interference, and we'll talk about that a little bit. How do we avoid those interactions between transmitters and or even the receiver part? We kind of took care of. If we do antenna distribution correctly, the receiver-to-receiver interaction we don't have to worry about. But there's still transmitter-to-transmitter interference that could potentially happen. We also have to worry about outside interference. We've been talking this whole time about TV stations. Well, they're a source of interference. So we'll chat about those things, and then we'll also get to actually coordinating the frequencies and how do we do that. So the basics of the compatibility issues are some of this probably goes without saying. You have to have separate frequencies for each wireless microphone and a receiver tuned to that frequency. Just like you wouldn't tune into one radio station and be able to hear two at the same time. Well, actually here in LA you can almost do that because some radio stations are overtaken by Mexican radio stations right down over the border. Anyway, that kind of goes without saying, right? Frequencies must be coordinated. It turns out that, as we're going to talk about in a little bit, you can't just go willy-nilly about just throwing some frequencies up and getting them operating. We got to avoid those local TV broadcasts, and then of course, it depends on where you are because TV stations change based on your location. It's not unusual for us to get a call saying, well, I was playing a gig in LA last night and it worked fine, and I went to Sacramento and it didn't work anymore. Well, TV stations change depending upon where you are. And then, of course, it depends on how many channels you have up and operating as well, or you want to get up and operating, I should say. And that includes any existing system. So if you're going into a corporate gig and they already have 4 or 6 channels or something up that they want to have operating, you need to take those into consideration when you're doing your coordination stuff. So let's chat a little bit about the system-to-system interference first. So the compatibility issues are that, first of all, we have a minimum frequency separation. How far apart regarding frequencies do my transmitters have to be from each other? And this is, of course, assuming that you have a wireless system that has selectable, tunable frequencies. Most of them these days, I think, are. Also, the transmitters, when two are on, they create what's called intermodulation distortion products. And as we'll see, those can wreak a lot of havoc. So first on the minimum separation. So we've already clarified each system must operate on a unique frequency. And what's the distance apart each one needs to be? Well, it depends on the quality of the receiver head end. At the low end of Shure's products, they need to be about 1.5 megahertz apart. A lot of space between transmitters. On our high end, we actually have a system that can go as little as 250 kilohertz apart. So really packed in very tight. That really is a function, as I've mentioned again, of the receiver's ability to filter and see the transmitter clearly. Here's a kind of a nice little pictorial that hopefully further displays this. If I have a transmitter on the air, let's just say this is 600 megahertz. If I try to put another one at 600.1 megahertz away, I'm actually still in the window of that receiver's ability to tune to that frequency. So it wouldn't work. I'm too close to the other transmitter. My receiver would be able to see both of those, and what would result is interference. Neither transmitter would work reliably. However, if I placed one at 603 megahertz, now I'm far enough away, I mean it's 50 dB down point, that I'm good. No problem. We should also point out here that this intermodulation problem is based on the linearity of this receive circuit, the transmit circuit. So on the left-hand side, we have a typical analog UHF system. And as you can see, I have a carrier 1 and 2. Those are 2 transmitters on the air. But what are these other little spikes next to it? These are my intermodulation byproducts. And it turns out if you happen to throw another transmitter on one of these intermodulation products, you're going to have unreliable RF use. The pictorial on the right is our ULXD system. You've heard me say a couple of times, moving forward and where products are going, we need to have products that are much more spectrally efficient. ULXD represents that. It's a much more linear circuit. So the same two transmits on the air don't create those intermod byproducts. This also happens to be the system that we can pack really close and tight together in a small space. Gets lots of channels on the air. Yeah, so this kind of just goes without saying, basically the same thing we just talked about, right? So let's talk a little bit about these intermods. Let's say I want to get two channels up and operating, channel 590 and 595. Well, the reality is those two transmitters within proximity to each other can interact with each other and create these other intermod products. We know that. These are predictable. We know what they are. There's actually another formula for this. And it is simply, for one transmitter is 2 times that frequency minus the other frequency equals your byproduct intermod. Same thing on the other side. 2 times that frequency minus the other frequency equals your intermod product. So if you're doing 2 transmitters with a calculator, you can figure out your intermods and steer clear. However, if I use 3 transmitters, now I have these byproducts right where these 3 are interfering with each other. And it creates a third set of intermods. 3 other frequencies from that intermod product. This too is predictable. It simply is frequency 1 plus frequency 2 minus frequency 3 equals intermod 1. You get the picture, right? Totally predictable. But there is another set of intermods that happens here. If I want to add a 4th transmitter, what do I really need to know? There's actually a 2 transmitter intermod section that we got to look at. I got way too many button clicks in here, I'm sorry. So, 3 systems on the air. The reality is I have 12 frequencies that I really need to pay attention to with just 3 systems. So you can see now we're guessing at a 4th frequency or trying to throw something out really is not an option, because you might land on one of these other guys and, again, have unreliable RF performance. So this is just a neat little kind of factoid. This is 9 frequencies up on the air and running. And it's kind of hard to see, but the red peaks are the actual transmitters. Everything else are the intermods. So could you look at that and guess where you should put your next one? Probably not. If you had a really fast calculator and could figure things out, maybe you could figure out where the next one goes. The reality is this is where the computer becomes our friend. or we just use the tools the manufacturers have given us on the wireless system. So in this case, we're looking at this screenshot of a ULXD. And most wireless manufacturers do this now. They have preset their wireless systems with groups and channels that are compatible with each other out of the box. So let's just assume you have no television stations online right now and your RF spectrum is completely clean. If I pick a group 1, I can just set all the rest of my receivers to group 1 and change the channel for each one of those. And that will be a coordinated, compatible group of frequencies that is known to work without issue. Again, most manufacturers are doing this today. Sometimes we'll get the call, systems aren't working too well, and we'll say, well, what do your groups and channels look like? So, well, we got one on group 1, channel 2, the next one's on group 3, channel 6, the next one's on group 8, channel 2, and then, whoa, wait. The problem with that, again, is already called out. That's not a coordinated frequency set. We don't even know that is. The other problem with that is some frequencies are actually shared between groups. So it's possible that group 1, channel 4 is the same thing as group 6, channel 7. It could be the same frequency. So you can see how it's important to stay within the same group, pick a different frequency. Avoiding active TV channels, how do we do that? Well, of course, we can look up in the database. We can find out where they are. We also have to know that if we're outdoors, you're going to be way more sensitive to those on-air broadcasts. So, you know, if you're trying to figure out what TV stations are on the air in your outdoor event, you should probably look for TV towers that are operating within 60 miles of your space. If you're doing an indoor event, usually the shielding of the building adds some good places for us to go and hide in the gap, so to speak. So we only have to look out maybe to 40 miles, 30 to 40 miles for TV antennas on the air. And as previously mentioned, channels differ based on what city you're in. So every time you move, you need to be aware of that. You can look up in Shure's frequency finder, enter your zip code where you are, or city and state, and we will give you the known on-air TV channels. And we'll also tell you, because this requires you to select what wireless system you're using, and the bottom half of this section will say, hey, you're using UR, so G1 in this scenario, you get about 26 channels up and operating. You should use group 10 because you get the most channels operating out of group 10. If you want to use H4, there's 26 channels compatible there, J5, 30, etc. Kind of get the picture here. Please note, we just changed our frequency finder, so it doesn't quite look exactly like this anymore, and it also takes into account low-power TV stations. What that means is if you did a design and you went online and used the old frequency finder and plugged in your information, and it says you can get a gazillion channels up and operating, and then you go to our frequency finder today and you plug in the same data, it might tell you you can't use any frequencies because it's taking into consideration these low-power TV stations. The reality is, now more than ever, going forward, based on everything we've talked about today, it's important to actually go on site and do scans. So what do you do that with? How do you do that? Wireless mic receivers have scanners built in these days. There are handheld devices. There are $50,000 spectrum analyzer scanners. Shure also makes a spectrum analyzer called the AXT600. This is an extremely valuable tool if you just want to have one in your kit, if you're a production guy or something, rental house. This is a good extra tool to have to go out on site and do these scans. The Spectrum Manager also provides other functionality for Shure receivers. It can actually deploy new frequencies to other networked Shure receivers as well, and it can monitor your RF environment and backup frequencies and all that kind of stuff, and actually visually show you which are the next best frequencies to go to if you take a hit. On a ULXD system, scanning is as simple as this. You can simply select channel group, you hit scan to continue, it does a scan, and that's actually real time. It's very fast. It tells you what frequency to go to, and then it's going to say, now you need to sync your transmitter. So you grab your transmitter, you do a sync, you're good. So it's scanned, it's avoided all the DTV stations on the air, and any other wireless transmit that may be operating at that space too. The good news about this, you didn't have to get your calculator out, right? So if I'm on site, I've got 8 channels or 20 channels of wireless, the best thing to do is hit your receiver scan, sync the transmitter, turn the transmitter on and leave it on, do another scan on your next receiver, sync the transmitter, leave it on. So this is a great way to do coordination between, like if you're doing your breakout rooms. You got several rooms going divided by air walls. What's the best way to coordinate for that? Because they're in different rooms. Well, we could do that in software, or you could just simply do scans and syncs, and then your transmitters and your receivers in each room will be good, clean frequencies. Does that make sense? Yeah. So, as we had talked about a little bit earlier, DTV stations take up that 6 megahertz chunk, and it's the whole thing. The old days and the analog days, it was really 3 different carrier frequencies, and we could tuck and hide inside of that TV channel all day long and get all kinds of systems up and operating. Now there's no way. If you have TV station on the air in your space, and it's high enough power, your wireless system will be completely useless if you park it on top of that DTV station. So, to maintain system compatibility, we want to make sure that multiple wireless microphone systems will work together. And if all systems are in the same frequency band, simply set them to the same group and choose a different frequency, different channel. I failed to mention that earlier. If you have multiple different frequency bands, of course, the group and channel thing goes out the window. Make sure that the channels you choose avoid DTV as well by either consulting the online database or using the receiver scanning available. And then otherwise, you got to calculate all this stuff by pen and pencil and calculator. When you do calculate that way, if you choose it, you got to maintain that minimum channel-to-channel spacing, observe the channel-to-intermod spacing, and avoid DTV. And again, most of the time, you're just not going to do this. We don't do it. Why? There's computer programs that can do it now. So this is where we talk a little bit about wireless workbench and spectrum manager. So if I have time, what I'd like to do real quick is jump over to wireless workbench. Are there any questions so far about what we just talked about? All right, moving on. What I have here sitting right in front is a QLXD receiver. The QLXD receiver is a networkable device. Any device that has a network port on it from Shure is accessible via one of our free softwares. So I have it networked directly to my computer right now, and we'll see it as I click on the inventory tab of Wireless Workbench 6. This is Wireless Workbench 6, by the way. It will auto-populate as it has done here. It's just recognized I've got a QLXD4 in my inventory and we're good to go. Now, I could go in and pick a specific frequency and say, I want to plot this at a certain frequency, and it'll deploy that frequency to my receiver, no problem. But if we're really going to talk about frequency coordination, unless somebody's handed me a list that says program all your equipment to these frequencies, chances are you're performing this function. So in Wireless Workbench 6, you can go to frequency coordination, and then down the right-hand side here are some tabs that kind of display what your workflow would probably be like when you're doing a frequency coordination. I'm going to jump around just a little bit here, but if we go to scan data, you'll notice that I have some options here. I can perform a live scan. I can import from hardware. Some of Shure's devices, like for instance Spectrum Manager, is able to do a scan and store that scan. And I can pull that scan out of it and bring it into Wireless Workbench. PSM 1000 body pack transmitters actually also have the ability to go out in the space, do a scan with the body pack, sync that back to my transmitter, and then be able to pull that into Wireless Workbench and use that. Or if I have saved scan data, I can actually pull it right from my computer. So in this scenario, let's just perform a live scan right here. And I'm going to use my QLXD right up here for that. The system's asking me, what do you want to use? I'll say, well, I'll use my G50 device that's connected. Bear in mind, if I had a rack full of receivers, they would all show up here, because anything with a network port that's a receiver, we can scan with. You pick one, you'll notice that the green section has lit up here. That's displaying the frequency band of that receiver. So again, this is a G50 device. It can only scan the frequency range in which it operates. It's not going to scan full band, just whatever it operates in. And again, start, and you'll notice automatically we're seeing this thing populate in. You might notice on the front of the receiver too that it's in this mode where it's scanning. You definitely don't want to do this when your talent is singing the top note of the national anthem, because it'll knock that transmitter off the air. Receiver becomes useless for that. So, but it's providing all this other great data. And we'll see some transmits come up on the air. Those single spikes, those are transmitters. We have some PSM 1000 and 300s and stuff back there. That's probably what those are. We've got some DTV stations on air coming on. I think channel 20 is, that's life safety. Channel 22 is going to be a TV station, I believe. However, look, it's pretty low power in here. So as this marches along, you may also see this red line across here. This is called our threshold. And it sits at about minus 85 dBm. What that's telling the program is that anything that's below that line, you can ignore. So I could have transmitters on the air and it will coordinate for anything. It could set something right on top of this chunk of stuff here. Although we wouldn't want to do that in LA because channel 14 and 15 is public safety. But at any rate, anything above is fair game to coordinate wireless microphones in. You might say, but Chris, how do we know what TV channels are on the air if I really want to avoid them or public safety? And I would say, well, you want to probably go to change TV channels. And this again allows you to enter in a postal code. And we're going to enter one in for right here at Empire, which is 90201. And the radius, I'll leave it set to 50. That's where it defaults to. And I hit search. And you'll notice it populates from the database here all the on-air TV channels that are within 50-mile radius of that zip code. And if we look down here, look, channel 14 is safety. Channel 15 is public safety. They're all public safety, 14, 15, 16. So I can save this, and now, can you see the red highlighted lines that show up here in Wireless Workbench? Channel 14, 15, and 16 all have red now. The program will not coordinate any wireless microphones on top of those red highlights now, the TV channels. Okay? So let's say we're good for now, but you know what? I have more than just one wireless system. Let's say I've got some SLX. So I can add devices here. For those of you that know SLX, SLX is not a networkable device, but of course, it's existing in this venue, so I want to select it. And let's say we have 4 channels of G4 in there. I want to add that. Let's say we have some, let's not pick J3 because that's ugly. Let's pick some G5. Add. And you know what else? We've got some BTRs. Is this going to be in my frequency band? Pick that one. Add. Okay. Close. Well, let's add some in-ears. Why not? We just bought some PSM 300, which is killer, by the way. If you haven't heard PSM 300, we've got a setup back there. You can listen to it. Okay. So maybe you noticed that my GLX-D4 is bold, and the rest of it looks kind of grayed out. That means it knows my GLX-D4 is live on the network. Anything else that would be live on the network, I'd be able to be seen. Of course, none of this stuff is networkable, so that's why it stays grayed out. The frequencies are set to find best. I could automatically, again, go in here and plug in a specific frequency if I wanted to, but at this point, I'm just trying to get a coordinated frequency set for all this gear to get it up and operating. So I'm going to jump back to my frequency coordination. And I've already done my channel scan. I've entered in my TV channels that I know about. I can hit calculate new frequencies. So automatically, we have gone through this process and it has populated. It says, okay, SLX G5, I got your 4 out of 4 frequencies. SLX G4, I only got 2 out of 4. I got my BTR base station, QLXD, PSM. We're good to go. You may notice here that there's compatibility settings here, standard. We can choose between standard, robust, which gives us more spacing, a more robust RF system, or I can choose more frequencies. Frankly, here in LA, it turns out that you're going to be finding yourself looking for more frequencies quite regularly. If you don't know it, you live in one of the worst RF environments in the US. Okay? So let's look for more frequencies and see if we can get stuff for that SLX up online. We may not, but I'm gonna hit recalculate. It found one more frequency, so I've got up to 3 now for SLX. I'm gonna have to go to a different band somewhere else with some other receiver to get another channel of RF operating, if I'm sticking by what my computer says will work. From this point, you can deploy this frequency set to all of your inventory, which is a good idea. You can also export this information into a coordination report. This is kind of nice because you can show a lot of information here, something you can hand to somebody, literally. It'll allow you to put in venue name, the address, phone numbers, all this kind of stuff. But the meat of it is here, this coordination report. It's showing you what zone you're in, because by the way, you can do separated zones. Again, this comes into play if you're looking to do multiple room settings or stages. Maybe you're doing a stage festival and you got 3 or 4 stages set up. You can zone those out. But within the zone, here are all my settings, what group and channel, if that's the case, and then what frequency that's assigned to. Notice that Wireless Workbench plopped a bunch of stuff in different groups and channels. How is that possible, Chris? You said don't do that. Well, groups and channels kind of go out the window when we're doing coordinated frequency sets this way. The computer now is running its database to populate those coordinated frequency sets, and you should be completely comfortable in using that setup. No issues, no compatibility issues. Cool? So we can deploy that to the inventory and close out, and now you'll notice in our inventory over here, there's multiple frequencies available. One last thing before we move on to the next thing. Wireless Workbench allows you to also remotely monitor any of your networked wireless devices. This departs from our frequency coordination thing, but I wanted to show you before we didn't have the ability to. I'm now looking at my receiver, my QLXD receiver, and if I had turned on a transmitter, let's see if I can step on something accidentally. Hope not. Demo failure, sorry, no batteries. At any rate, this would populate with all the good information. It'd show me RF audio levels, battery life. It'll show you hours and minutes if you're using our rechargeable solutions. So this is another great tab to know about if you are doing any kind of production work. So we'll have the ability to see Wireless Workbench and lots of other products back there. This kind of does it for my end of the presentation today. Please ask any questions that you need. Ben is in the back. The Empire guys are around. I'll be around for a little bit. But hopefully you'll walk away today knowing how to coordinate and antenna setup and everything else you need to know. Sure. Any questions? Yes?
Can you quickly go over backup frequencies and how it works with stuff that auto-populates in the system, like QLXD and all that?
The question was, talk about backup frequencies and how it might populate. So if I go back to my inventory setting here, and let's say I want to add ULXD 4, let's just add that one, that's fine, G50. Oop. I have to tell it how many devices that I have first. In this case, that happens to be a dual channel receiver, so it's going to calculate for 2 frequencies. But the next little box over, it says backup frequencies. This is a cool extra feature. I can say, I want however many backup frequencies to calculate as well. I'll say 2. I add that. If I go back to my frequency coordination page, remember I just coordinated frequencies for all this other stuff? Well, I don't want to re-coordinate that, so I can go to my channel summary. These are all my channels that I have frequencies for. I can select, in this case, I'll make it quick and easy. I'll say select none, and then I will go down here and physically select the 2 ones that I just added, and then look down here at the bottom, I've got backup frequency list as well. I can select those because obviously I need frequencies for them. I click OK, I hit calculate new frequency set, and now you'll see it hasn't populated anything except ULXD, It's given me my 2 primary frequencies and my 2 backup frequencies. What happens now? Well, you can print out a list and it'll show you your backup frequencies for whatever you've asked for. And then you can manually go and change them. Or if you have a spectrum manager in your system, which is a single rack space device, you've seen it on a former slide, we have one in the back. This information will get deployed. If I was networked to it, this drop-down would show me a spectrum manager. And I could select spectrum manager and say, deploy this to spectrum manager. It will monitor those backup frequencies in real time. If I take a hit on one of my primary frequencies, I can remotely or on the front of the spectrum manager say, deploy that new frequency. Which is amazing, that's great, except if I'm using a system other than Axient, which is our premier wireless system, you have to physically sync your transmitter to your receiver. So the receiver got that new backup frequency, great, but now your transmitter's lost. So you need to resync and you're off and running again. Axient does all that in real time if you have all the pieces and parts. You deploy a new frequency and it happens against all the transmitters and receivers that need to change.
One follow-up. So when you switch to the backup frequency, does your primary frequency, from my understanding, that gets shuffled into your backup frequency?
Oh, this is a great question. So what happens to that primary frequency that took a hit? Spectrum Manager degrades that frequency. It still monitors it, but it degrades it, and it's basically it's like a stoplight. It's red if it's not good, it's yellow if it's working its way out, and it's green if it is good. That frequency will fall to the end of the list. Spectrum Manager will monitor it over time, and at some point it will move up to a yellow status, which means, well, it's been good for a while, but we knew it took a hit. It could move back up to green, but it will never move higher than another frequency that has not taken a hit. So it still categorizes even the good backup frequencies.
Any other questions?
Thanks so much, guys.
How about a round of applause? Thank you, Chris. That was great. Did everyone find that useful? Awesome. We're going to take a really short break, roll right into QSC. They're going to do the line array and amp technology presentation. I'm going to do a couple quick raffles. If you guys haven't, is there anyone that hasn't signed up? Everyone should be signed up. Again, to earn additional raffle tickets, follow us on Facebook, Twitter, any of that. Show me. I'll give you an additional raffle ticket for every single one that you follow us on, and that'll increase your chances of winning. Real quick, by show of hands, how many people here are Empire Pro dealers? Yeah, most of you guys look familiar. How many are not? Cool. So if you guys have any questions regarding becoming a dealer, come see myself, any of the guys. Most of them are wearing Empire Pro shirts, but we're happy to help you. So quick 5, 10, maybe 15-minute break. Restrooms over here. We still have a couple bagels, but we went and got lunch, so lunch is on the way. And if you have any questions, let us know. Most of the guys are in the back, so you got the Shure, QSC, and Yamaha booths in the back if you have any questions. And that's it. Cool. All right. We'll do a quick raffle here. If you want, come show me real quick. I'll give you an extra ticket. We'll do one while we're waiting. So we're going to save the big prizes for the end of the day. At the end of the day, we're giving away a Chrome ULXD system. It's a one-of-a-kind, about a $1,600 value. We're going to give that away at the end of the day. We have a QSC amp that we're giving away. And right now we're going to give away some swag. I'm going to check these guys and give them their tickets, and we'll do it in a moment. Guys, oh, sorry. If you're looking for how or where to connect with us, If you go to our home page or any of our emails, in the signature or at the bottom of the home page is a link to every profile page. And rather than searching for us in the program, you can just go, it links you directly to it. So you just go to our home page, scroll down to the very bottom, there's an icon for each one. You could just hit each icon, click follow, and that'll be a quick, easy way for you to find us on the social networks.